Alright, so let's talk about permutations. And the first thing you're going to see is this 5 and exclamation mark. So that means 5 factorial. And what that means is we start with the number 5 and we just multiply, which is a factor, every number that comes before it. So that would be 5 times 4 times 3 times 2 times 1. So 5 times 4 is 20. 20 times 3 is 60. 30 times 2, oh, I wrote 30, not 60. 60 times 2 is 120, and then 120 times 1 is 120. So 5 factorial would equal 120. Alright, now we'll go over the fundamental counting principle. So a log has 5 numbers, each number can be between 0 and 9. So there's 10 digits between 0 and 9. And so each number on that log could either be one of those 10 digits. So if you think about a log, we'd have numbers on this, and we divide it up. And each number can be a different number, or it could be the same number. So you could have a combination, 1, 1, 2, 3, 9. It could be anything. There could be lots of combinations. Well, the point of that is there's 10 different ones for each one of these little spaces. So the counting principle says to know how many different outcomes we could have, we need to multiply all the possible outcomes for each one by the other one. So this would be 10 times 10 times 10 times 10 times 10, or a 1 with 5 zeros when we multiply that out. So there's 100,000 possibilities for that log. So if you're just guessing on your combination, it's going to take you a little while to get the right combination. Alright, so let's talk about permutations. And in a permutation, the order matters. On that last one, it didn't matter on the log, it didn't matter which number came before which number, because each number was independent. On a permutation, the order does matter. So if we had, like on a log, so say we had 3 numbers this time, but the numbers can't be repeated. Meaning once a number is used, it can no longer be repeated. So again, we start with 10. So say that's our combination. But the number can't be repeated, so once the 1's used, we can't use it anymore. So then we have 9, and then we would have 8 numbers left to choose from. So the way this is written would be, we're doing a permutation. There's 10 possible, and we're picking 3 of them. So it would be 10p3 is the way you would read that. So you would do 10 times 9 times 8. So 10 times 9 is 90. And then times 8 would be 0. 9 times 8 is 72. So that would be 720. So 10 permutation 3 would be 720. Alright, so we're going to do 2 more. So we have 8 different choices permutated with we're picking 4 of them, and then 12 permutation 2. So this first one, we have 8 possibilities for the first one, and we're going to do this 4 times. So each time, remember, we lose 1. So that would be 8 times 7 times 6 times 5. Whereas in the second one, we have 12 different options, but we're only picking twice. So it would be 12 times 11. So let's now work these out. So 8 times 7 is 56, times 6 times 5. I'm going to do the 6 times 5 next, because this is all multiplication, so it doesn't matter which order we do stuff in. I just know my multiplication is going to be a little bit easier doing that. Alright, so we're going to have a 0 placeholder, and then 6 times 3 is 18, carry the 1, 15 plus 1 is 16, so it would be 1680. And then 12p2 would be 12 times 11, which would be 120, 132. So you get a lot more permutations for 8p4 than you do for 12 permutations of 2. Alright, we'll do one more. So how many ways can a coach arrange his 5 players on the basketball court? So we got 5 positions. So the first one has 5 options. Well, once we've used one for that first position, we only have 4 left. So that's going to be 4 left for the second one, 3 left for the third one, 2 left for the fourth one, and then 1 left for the last position. So really what you're doing here is 5 factorial. So 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, so that equal 120. So there's 120 different ways the coach could arrange those players.